is a short lecture. We're just kind of catching up on a couple things that I didn't get time to get to in our very first lecture, our very first class. And there's some important info in here that I really think is important for you guys to know. It's kind of the more technical part of welding. It's about the electricity and how this stuff works. But this is really useful stuff and really important. So a review real quick of the different terms we're going to use here. So first is amps versus volts, and you've heard me talk a little bit about this. And what you control on the front of the welder is the volts, not the amps. So the difference here is an amp is a unit measuring the quantity of electrical current, and a volt is the unit of measurement of the electrical current under pressure, or the electrical pressure that's occurring with that current. So the analogy that's usually used with electricity that helps me out a lot is this water in a pipe kind of analogy. So if you think about water in a pipe or in a hose or in your faucet, coming out of your faucet, an amp is the amount of water flowing. So it's the amount of water coming out of that pipe. And a volt is the pressure of the water coming out of that pipe. So the pressure changes depending on how big or how small the pipe is. Or if you think about a faucet, like how much you turn it on or keep it low. Or like in a hose, how much you put your thumb on the hose and you can spray it and you can make it come out at a higher pressure. So that's a really important difference, and it's really valuable to be able to know the difference here. So you can kind of try to keep these clear in your head and understand what it is that you're controlling and how. And then more terms here. So we have AC and DC power. They're two different kinds of electrical power that could go into your machine or that your machine can use, basically. Your machine can output. So AC means the charge, the negative and positive, is flowing. The direction it's flowing changes very, very rapidly in milliseconds. So it'll have this wave form look that you'll see illustrated if you're talking about electricity and even in welding. And then with DC is direct current. So the electrical charge only flows one direction always. So AC, alternating current, it goes back and forth, positive, negative, positive, negative. DC, it only flows one direction always. So that's AC versus DC. A lot of TIG welders, you'll be using AC current. On some stick welders, it's AC. For most MIG welders, it's DC, direct current. And then, again, more terms. These are kind of trying to keep all these things clear in our head. We have constant current versus constant voltage. This is the power source. So the box that you have, the machine that you have, can only do, it can do one or the other, or it can do both. A lot of our machines, the newer ones now, are able to do both. So this differentiation sort of starts to get a little fuzzy. But a constant current power source is one that maintains that current. That current is the amperage. It maintains that at a constant level, and then the voltage changes. So you're changing the voltage, and it maintains the current. So the volt fluctuates with the arc length in a constant current power source. With a constant voltage power source, it maintains the voltage at a constant level, regardless of changes in the current or amperage. So constant voltage means that you set the voltage on the machine and it maintains that voltage constantly no matter what else you're doing with the machine. So, when you're welding, when you're MIG welding, your gun can go up or down. You can change the current, you're change the angle. You're changing things different things are happening when you're welding, but your machine is going to maintain the voltage that you told it to maintain regardless of what else changes. So we are using constant voltage machines for MIG welding or for GMAW. And then some more about CC and CV. So the next step in here, as you start to try to understand this, is that this term constant is actually relative. So even though you set the voltage, to 10, say, and it's going to maintain relatively constant at 10, but it does fluctuate a little bit. If you have a constant current machine and you set the amperage is going to fluctuate a little bit. So what's happening is that the power source monitors the arc and makes changes in order to maintain a stable arc condition. So that you remember with stick welding, if you get too far away, you lose your arc, right? The same will happen with GMAW, but it's a little bit harder to mess it up with GMAW. But the machine itself is sort of like monitoring what's happening in all those different changes that are happening with angles and distance and everything, and trying to maintain a stable arc condition so you actually could still weld, right? That's the idea. So there's newer machines. You talked a little bit about newer machines previously. So some of the newer machines, they can pulse the power, so they could go a high voltage and a low voltage. Or you can use things called waveform control technology. So you have, it just gives you more and more, these newer and newer machines are giving you more and more and more control, a more precise control. If you've done any TIG welding so far, you've probably have seen a machine where you use some pulsing on the machine. You might have seen something about changing, working on the waveform. But they have newer machines now that can do this with MIG as well. We don't have any at the shop, of course, but I just want to sort of prepare you for what you might encounter out there in the world. So these newer machines, with all this pulsing and the waveform and et cetera, they're not actually technically truly CC or CV. So they're doing so many different things in order to maintain, the best, most optimal arc possible, that they become something different. They're not strictly one or the other anymore. And if you look at some of the power sources, if you're using any of the suitcase welders, the V-Sense feeders, you can see that I think most of our power sources, you can switch them from constant current to constant voltage. And that lets you use that power source for stick welding, TIG welding, and MIG welding. All right, so that was a little technical electricity stuff. Now we're going to talk about technical stuff with sort of some of the procedures and techniques, but this is a little bit more directly applicable to your actual welding as you're doing it. So some terms here for this. Some terms you'll hear thrown around are extension and stick out. So there's two differences, but they kind of get used in the same way interchangeably, but they are a little bit different in some welders. It depends a little bit on the kind of welder setup that you have. So extension is the extension from the contact tip to the end of the electrode, that distance. Stick out is the visible stick out. So it's from the end of your gas nozzle to the end of the electrode. Sometimes you'll go and look at the welder you're using. A lot of them, the contact tip and the gas nozzle are flush. The gas nozzle doesn't come down past the contact tip, so it looks pretty much the same. It's good. You're not going to see a difference between extension and stick out. Some machines you will, and if you're looking at a welding procedure or some directions or something that tell you, they're talking about stick out or they're talking about extension, you'll want to know that difference so you can actually get the right length that they're trying to get you to get. So stick out is the visible electrode. Extension is all the way from the contact tip to the end of the electrode. So making changes in the extension is going to change some of the ways so that you change some of the parameters of the weld. So if you have a longer extension, you have going to have a lower amperage. So you're going to have, basically it translates to a little bit less heat, if you will, less electricity, less water in that pipe there. But it's good for welding super thin stuff because it'll prevent burn through a little bit longer. You can't obviously be too far away, but a little bit longer extension can sometimes be good for welding thin sheet metal. A super short extension means that you have less wire for resistance heating. That resistance happens with electricity. So you have a more amperage and therefore greater penetration. So that's good for if you're welding thicker material. So it's a good just sort of general, another little extra thing that you can play with as you're welding, your extension there, how long your electrode is or how far away you are from the metal kind of. And then we talked a little bit about this when I was doing our first demonstration. I know we haven't had a lot of time to practice this yet, but we will. So you can do backhand or pull welding, or you can do push welding, when you weld away from yourself. So backhand is welding back towards yourself. The welding gun points back at the weld. The weld progresses in the opposite direction. You know, your weld is here, your gun is here. It progresses opposite. There are differences in pull welding versus push welding. So backhand pull welding, there's a more stable arc condition, less spatter, and deeper penetration. So again, a little bit better if you're welding thicker material. Forehand or push welding, that's you're pushing the weld, you're laying the weld down like this, and you're pushing it along away from you. This is recommended for if you're welding aluminum, which we are going to try later this semester. If you're doing spray transfer or pulsed spray transfer modes, which we will try spray transfer. We have one machine that can do that. Compared to backhand welding, you have more spatter, which is not so great usually, and then less penetration, which would be better for thinner stuff. But you have better seam visibility. It's a little bit easier to see the seam of your weld because you see it right in front of you. So it's a little easier to follow along with the seam and see ahead of you what you're doing. So some people might prefer one or the other, be a little comfortable with one or the other, but you should be able to do both. And there's going to be times where you would want to use one over the other. And then another thing that you are adjusting, that you are doing, is the gun angle. And it will affect these different aspects of the weld: penetration, the bead form, and the bead appearance. So there's two different kinds of angles that are important. There's the transverse angle, the work angle here on the left. So this is when the weld is facing right here, away from you. I'm pushing or pulling the weld here. It's the angle of my gun this way or this way. So you'll remember when I did the demo of doing that T-joint, I had the angle a lot farther down because I'm trying to fight against gravity to get up there on the top of the T-joint. If I'm doing just a groove weld on a flat piece here, then I don't have to have quite so aggressive of a transverse angle. And then you have the longitudinal angle, so that's when your weld is here in front of you and you have your gun this way or this way. So again, if I'm welding the correct way, towards me or away from me, it's the angle that I'm holding it, how far down my hand is or how far up my hand is. And one thing that I see a lot in beginners as they're learning is that as you're welding along like this, you're going to accidentally change your angle. It'll get your longitudinal angle, especially. It'll get more aggressive or less aggressive as you're sort of trying to reach farther in front of you. And that can be a big problem with your weld because it's going to look, you have a great angle set up in the first half of the weld, the first couple inches, but then you start getting out of position, your angle changes, and you're going to have problems with that second half of the weld. So it's really important to try to observe that as you go along and maybe do a couple tracing passes without actually pulling the trigger with your hood up and practice holding your hand in the same position. You got to just sort of train yourself to do that and make sure you can reach all the way along the weld and stuff like that. Oops. Yeah, there we go. Angle. So work angle and travel angle, or transverse angle, longitudinal angle. Do try to remember those. At least just keep in your head that those angles matter and how to adjust them yourself, even if you don't remember the names of them. And then bead patterns. We've already, obviously, you've worked a little bit on this, but just a little bit more information for you to think about as you're working on it and getting your weave to look nice. So the stringer bead pattern is similar to stick welding. It's just very little side-to-side motion. But in MIG, you don't just drag it. You still have some side-to-side motion. It's just smaller with a stringer bead. And it could be this kind of circular motion or a small zigzag motion. These are just kind of different ways to think about it in your head, and one or the other might sort of click a little bit better for your hands as you're moving. And then the weave bead pattern is also called a wash bead or oscillation bead. So that's a lot more side-to-side movement, much wider than a stringer bead. And then this sort of illustration here, I think it's helpful because it has these circles at each point of the weld. So that stands for a dwelling, a stopping a little bit in time for, extra half second at each end of the weld. And that is, you want to sort of figure out what the best pattern is for yourself, and obviously not pausing too long, but you do kind of pause a little bit, again, like a half second or so more on either side. This helps to prevent undercut, one of the problems that we've talked about in past lectures. And then just a little bit of info last, since we were talking about gun angles and stuff. In the 211 class, I've mentioned we don't usually do this uphill welding, any of the vertical up positions. We focus on flat and horizontal. But this is just to think about that angle and how it translates into the actual weld in the future. And you could try these welds anytime you want, of course. So for up welding, you have a much more, you weld from the bottom to the top of the joint. And then you have a very aggressive angle going up the weld there. So you're trying to push the weld pool up against gravity. And then if you're doing a multi-pass welds, like if you're passing, getting one of the certification and you're doing a multi-pass weld, the bead placement is the same for flat and horizontal welds. That means you do one in the middle and then one on the side and one on the side. That's just sort of some information to store in the back of your head there. And then for vertical down, you still have a pretty aggressive angle, but not quite as much. You're trying to kind of hold that weld pool and keep it from falling down in this case, and then just letting gravity pull it down without it kind of globbing into a big glob that is messy. Okay, so that's the end of the slideshow. This is a little bit of catch up. I know some technical information and stuff. But this really does matter for your welding, and it's really obviously useful and important information, and it will be on the midterm, which is coming up before too long. All right, if you have any questions, as always, send me an email. Have a good day. Bye. See you in class.